For several decades, Toyota has been known as one of the strongest names in the automotive industry, from being a symbol of durability to becoming a pioneer in hybrid technology. And now, in our time, the fight for cleaner and more sustainable transportation is in full swing. This company is taking a new step that could change the course of the entire industry. While many companies are focused only on battery electric vehicles, Toyota chooses to explore broader solutions. From hydrogen-powered engines to water-powered technology, ideas that once seemed impossible but are now gradually becoming a reality. It's not just about creating a new engine. It's also about reimagining driving in a world that's more conscious of the environment. And if it succeeds, it could change not just Toyota, but also the direction of the entire automotive industry. In this video, we'll examine the history, technology, benefits, challenges, and consequences of Toyota's innovative engines, and how this could possibly set a new standard for the future of transportation. But before we begin, don't forget to like and subscribe. That means a lot to us content creators. Thank you. And now let's get started. Toyota's engine history. From humble beginnings to becoming one of the biggest innovators in the automotive industry, the story of Toyota's engine is full of perseverance, ingenuity, and long-term vision. If we go back to the earliest stage, Toyota's engines were simple back then, just enough to work, but not too complicated. But during World War II, they were making standard-sized trucks for the military. That period was important because that's when Toyota's foundation in engineering began to strengthen. After the war, the direction of the company gradually began to change. They started making more diverse engines and improved their designs. In the 1950s and 60s, they introduced the R-Series engines known for their durability and reliability. These became the heart of some of Toyota's earliest and most successful cars, serving as a symbol of their commitment to quality. By the 1990s and early 2000s, their progress accelerated even more. They launched the 7AFE Lindbergh engine, which helped reduce pollution, and also introduced the variable valve timing intelligent mechanism in engines like the 2JZ-GE to improve performance and fuel efficiency. When the new millennium arrived, they entered hybrid technology through the 1NZF-XE, the world's first engine for gasoline-electric hybrid cars. This shows Toyota considered the environment before it was widely recognized. In the past 10 years, they not only continued this tradition, they even accelerated it. The dynamic force engine family was introduced. Engines that are extremely fuel efficient without sacrificing power. These are used in models like the Corolla and Camry. It's a balance of performance and efficiency that's rare in the industry. And now in the year 2025, they are once again on the verge of a major change. They are now venturing into hydrogen-powered internal combustion engine technology and water-powered engines. These are ideas that could completely change the way vehicles operate. Imagine an engine that only emits water, using the most abundant element in the universe, hydrogen. If this succeeds, it won't just change emissions and efficiency. It could totally change how we view vehicles' global impact. Questions remain like, how will it perform on actual roads? What does it feel like to drive a car that only emits water? The answers to those questions could redefine the meaning of driving. One thing is clear, Toyota is at the forefront of this revolution in the automotive industry. Why did Toyota choose hydrogen? At a time when the use of electric vehicles is gradually becoming normal, Toyota is heading in a different direction. They are making engines that use hydrogen as fuel. And this is not just an experiment, but an idea that could change the course of the entire automotive industry. But why hydrogen? And how does it work in an internal combustion engine? In comparison, a hydrogen-powered internal combustion engine or hydrogen internal combustion engine is different from hydrogen fuel cell electric vehicles, like the Toyota Mirai. In a fuel cell setup, hydrogen is converted into electricity through a chemical reaction. But in hydrogen internal combustion engine, it is burned directly just like what engines that use gasoline do. The biggest advantage is almost zero carbon dioxide emissions. The main byproduct is water and a small amount of nitrogen oxides caused by the mixing of oxygen from the air. But this is still lower compared to traditional engines. To make this possible, Toyota upgraded the 1.6-liter turbocharged 3-cylinder engine found in models like the GR Yaris and GR Corolla to accept hydrogen fuel. They added durable tanks for high-pressure hydrogen storage and modified the fuel supply and injection system. Hydrogen burns faster compared to gasoline. That's why it has the potential to provide quicker throttle response. This is a characteristic that's favorable in motorsport. And it didn't just stay on the drawing board. Toyota has already tested this in a race using the Corolla Sport race car with a hydrogen-powered G16E EGTS race engine. In the performance test, it proved that it can keep up with high-performance engines while producing less pollution. But Toyota's goal goes beyond just performance. This is part of a bigger plan. To achieve carbon neutrality by the year 2050, aside from developing hydrogen engines, they are also collaborating with companies to improve green hydrogen production and expand fueling infrastructure. In other words, Toyota combines the familiar design of traditional engines with the benefits of clean fuel. In this way, they're not just challenging the current electric vehicle-dominated market, they're also redefining the meaning of sustainable transportation and the environmental benefits of hydrogen engines. As the entire automotive industry quickly shifts toward more environmentally friendly technology, Toyota's hydrogen-powered internal combustion engines are emerging as a curious alternative. But how effective is it really when it comes to its impact on the environment, especially when compared to hybrid electric vehicles and plug-in hybrid electric vehicles? The first big advantage is clear. It doesn't emit carbon dioxide while running. Instead of smoke that harms the ozone layer, the main thing that comes out of the exhaust is water. Compared to engines that use gasoline, its impact on greenhouse gas emissions is much lower. The secret lies in the combustion process. When hydrogen is burned, it reacts with oxygen from the air and produces energy, with water as the only byproduct. There's no carbon, so no carbon monoxide, too, is produced. In comparison, even hybrids and plug-in hybrids still use gasoline, so they're not really zero emissions. There's another aspect that's often overlooked: the total environmental impact from production to usage. EVs and PHEVs require large batteries that use rare earth elements and energy-intensive processes to manufacture. With hydrogen engines, there aren't many battery components, and if renewable energy like wind and solar is used to produce hydrogen, the total energy required is even lower. When it comes to efficiency, hydrogen combustion engines are not left behind either. In some situations, it can even be as effective or have higher efficiency compared to traditional engines, especially under high-load conditions. With this setup, it can even compete with hydrogen fuel cells, which experience decreased efficiency when power demand is high. In these times when the problems of climate change are worsening and natural resources are depleting, Toyota's technology in hydrogen engines is like a light in the darkness. It's a way to provide clean, more sustainable transportation without sacrificing performance and practicality, performance and user experience, power, and driving experience. Is it possible for a hydrogen-powered engine to keep up with the performance of a gasoline-powered engine? The answer is yes, and not only can it match, but in some aspects it can even surpass it. One of the secrets is the speed at which hydrogen burns. It reacts faster than gasoline, so there's less delay from the moment you step on the accelerator to when you feel the engine's pull. For those who love quick vehicle response, this is a big plus. But the discussion isn't just about acceleration speed. Even though they use clean and modern fuel, hydrogen-powered vehicles can still provide a feeling that's familiar to drivers. That roaring engine sound, the instant pull, and the sense of control that feels like you're already used to it. For car enthusiasts, it's a big deal that the soul of the vehicle isn't lost. And this isn't just a theory. Toyota has already tested this technology in motorsports, where the pressure is high and there's no room for mistakes. In these races, hydrogen-powered race cars have shown that they can compete on equal footing with traditional cars when it comes to speed, agility, and durability. When it comes to power, they're not lacking either. By modifying existing engine designs to run on hydrogen, Toyota has managed to achieve horsepower and torque that can keep up with, and in some cases even surpass, gasoline-powered engines. And when it comes to driving pleasure, many who have tried it say there's no difference in the joy of driving this compared to a petrol car. In fact, it's like a combination of a familiar experience and new technology. A vehicle with the performance of a traditional engine, but with a clean and modern fuel source. In short, Toyota is bridging the gap between the present and the future of the industry. With hydrogen-powered engines, you can still enjoy your favorite performance while helping the environment. Technical aspects. Technical details of hydrogen engines. One of the most notable projects of Toyota in this field is the 1.6-liter three-cylinder turbo engine used in the Corolla Cross hydrogen prototype. At first glance, it looks like an ordinary engine, but inside it combines traditional design and modern technology. Its base design comes from the engine of the GR Yaris, a model known for its speed and agility, but to use hydrogen as fuel, it needed major modifications. First question, how do they maintain the engine's power even though the fuel is very different? The key lies in the combustion process of hydrogen. Handling and burning it differs from gasoline. Toyota used a high-pressure hydrogen direct injection system, a major departure from conventional fuel injection, to make the entry of hydrogen into the combustion chamber more precise and to maximize every drop of energy. Even so, the engine still achieves power and torque equal to its gasoline counterpart. The turbocharger plays a big role here because it provides extra air and power to achieve the expected performance. But there's a challenge. Hydrogen has a lower density than gasoline, so it needs a larger volume to get the same energy output. This is where the ingenuity of Toyota's engineers comes in. They adjusted the turbo and other engine parts to adapt to the unique characteristics of the fuel. When it comes to efficiency, hydrogen combustion engines have the potential to be even more efficient than traditional engines, especially in high-load situations. This means it's more fuel efficient while producing almost zero emissions, since water vapor is the main byproduct. In other words, Toyota didn't just simply modify an existing engine. They developed a system that can still deliver power and speed while contributing to the goal of clean and sustainable transportation. Toyota's approach to carbon neutrality, Toyota's strategy for carbon neutrality. As we move closer to a future with a tougher fight against climate change, Toyota's direction is clear. Achieve carbon neutrality with more flexibility and suitability for different regions worldwide without focusing on one technology. Instead, they are developing hydrogen technology and electric vehicles at the same time to provide more options. Why hydrogen? Because when it is burned, whether in a fuel cell or a hydrogen-powered internal combustion engine, the only emission is water vapor. No carbon dioxide, no smoke that can harm the air. This isn't just for private cars. Toyota also plans to use it in buses, trucks, and public transportation. But they also haven't turned their backs on battery electric vehicles, or BEVs. For Toyota, these are still important as part of something stronger. The difference between them and other companies is that they are not limited to BEVs. They know there are places where the charging infrastructure is weak or where electricity from renewable sources is lacking. That's why other options like hydrogen and plug-in hybrids are still needed. This is Toyota's approach. First, understand the conditions in each region. If there is a lot of renewable energy, BEVs are ideal. If there is affordable hydrogen production and refueling stations, hydrogen vehicles, whether fuel cell or combustion type, will come in. The plan goes beyond the vehicle itself. This also includes reducing carbon footprints in their manufacturing plants, using recycled materials, and investing in renewable energy projects. For Toyota, it's not enough to just sell green cars. Pollution must be reduced from production all the way to usage. This is why they use a multitasker, technology approach to cover different situations and achieve the goal of a carbon-neutral world more quickly. Challenges and potential of hydrogen engines. The challenges and potential of hydrogen engines. With Toyota pushing for the use of hydrogen as fuel for engines, there's no denying that this is a huge opportunity. But along with it comes a series of challenges that need to be overcome. The first challenge is infrastructure. Compared to gas stations and electric charging stations, there are still very few hydrogen refueling stations around the world. You can't just put hydrogen in any kind of tank. It needs a special storage and distribution system because of its high flammability and low density. To have a global network for this, it requires a huge investment and coordination between the government and the private sector. The second challenge is safety. Because hydrogen is highly flammable, there are concerns about its safety. This is where Toyota's engineering expertise comes in. They use durable containment systems and advanced sensors to immediately detect any leaks. The plan also includes providing proper training to drivers, mechanics, and even first responders to ensure its safe use. But despite the obstacles, hydrogen engines have great potential. First, it can provide zero emissions transportation when the hydrogen comes from renewable energy sources. Second, it can deliver performance as intense as traditional internal combustion engines, complete with speed, power, and driving feel that car enthusiasts love. Third, it can be more practical in certain applications like heavy-duty trucks and buses, where longer trips and faster refueling are more important. In other words, if infrastructure and safety issues can be overcome, hydrogen engines have a chance not only to be an alternative to electric vehicles, but also to become one of the main pillars of clean and sustainable transportation in the future. Toyota's water-powered engine initiative, Toyota's project on the water-powered engine. Imagine a vehicle literally powered by water, like a scene from science fiction. But at Toyota, this is slowly becoming a reality. This is what they call the Water-Powered Engine Initiative, a project aimed at delivering one of the cleanest and most sustainable types of engines. How does it actually work? The secret lies in the very composition of water. Known in science as H2O, it is made up of 2 hydrogen atoms and 1 oxygen atom. To use hydrogen as fuel, it needs to be separated from oxygen through a process called electrolysis, where electricity is passed through water to separate the 2 elements. Once the hydrogen is obtained, it is burned in the engine just like a traditional internal combustion engine. But instead of smoke or carbon dioxide, only water vapor comes out. This means the emissions are almost zero, and it doesn't directly add to air pollution. According to patent filings, Toyota is serious about this project. They are protecting the idea, and the technology behind water-powered engines is a sign that they see this as an important part of the future of transportation. But implementation is not easy either. An efficient electrolysis system is needed to produce hydrogen quickly and cheaply. Safe and reliable hydrogen storage solutions are needed for vehicles. An engine must also be designed to handle hydrogen's unique combustion characteristics. If you look at Toyota's track record in innovation, from hybrid cars to hydrogen-powered race engines, it's not unlikely that they'll succeed in this area. If fully developed, the water-powered engine could be a game changer in achieving true zero-emission mobility. Toyota's vision for the future of transportation. Toyota's perspective on the future of transportation. As Toyota continues to advance in research and the development of innovative engines, their direction is clear. A world where travel is faster, more efficient, and above all, better for the environment. Their development of hydrogen and water-powered engines is clear proof of their commitment to sustainability. But why do they choose these technologies? The answer is simple. Because these could greatly cut greenhouse gas emissions and aid the fight against climate change. Currently, battery electric vehicles still dominate the market, but Toyota sees its limitations: range anxiety, or the fear of running out of charge during a trip, long charging times compared to the quick refueling of hydrogen, and the environmental cost of producing and disposing of large batteries. On the other hand, hydrogen vehicles can refuel in just a few minutes. It's like a gas station, but what comes out is clean. By providing an alternative option, Toyota challenges the view that BEVs are the only solution to green mobility. Furthermore, they have aligned their plan with global environmental goals like the Paris Agreement. This means that these technologies are not just for competing in the market, but actually to help achieve the global carbon reduction targets. In the future envisioned by Toyota, it's not just about people being able to get from one place to another. They want to the Highways Hitler Perv. Its success mainly depends on the infrastructure. No matter how advanced the technology is, if there aren't enough places to refuel hydrogen, it will have a hard time becoming mainstream. This is where Toyota's plan comes in, to collaborate with different companies and the government to build more hydrogen refueling stations. It's more than building stations. Advanced storage tanks are needed that can hold hydrogen at extremely high pressure, along with safety systems that automatically alert if there's a problem. In Japan, Europe, and some parts of the United States, these stations are starting to increase in number. The goal is to make hydrogen stations as common as gas stations in the next 2 decades. Once this is achieved, it will be easier and more convenient for drivers to choose hydrogen-powered vehicles, which will speed up the global shift toward zero-emission transportation. Bonus topic 2, solid-state hydrogen storage, a new way of storing hydrogen. Another exciting development from Toyota's research partners is solid-state hydrogen storage. Instead of compressing hydrogen at extremely high pressure, it is stored in solid form using special metal hydrides. What are the advantages of this? It's safer because leakage or explosion is less dangerous compared to high-pressure tanks. It's more compact, making it easier to integrate into different types of vehicles, from cars to large trucks, and it allows for longer storage without reducing the quality of the fuel. If this technology succeeds, it could change the way fuel is used and the way hydrogen vehicles are designed. There will be more space for passengers and cargo, and people's concerns about the safety of hydrogen fuel will decrease. For Toyota, this is an important step to make the use of hydrogen as a primary fuel in the future more practical and consumer-friendly. Bonus topic: 3 hydrogen-powered public transport expanded, used in public vehicles. Toyota is not only targeting cars for hydrogen technology, they also have big plans for public transport. In some cities in Japan and Europe, they have already started deploying hydrogen-powered buses that have almost zero emissions while running. Why is this important? Greater impact on pollution. Because buses spend more time on the road compared to private vehicles, they can reduce the total carbon emissions more significantly. Switching to hydrogen fuel would speed up adoption. When public transportation uses hydrogen, more people will be able to see and experience this technology, which will increase awareness and trust. The efficiency is also higher. Hydrogen buses can refuel in just a few minutes, so unlike electric buses, they don't require long charging times. According to Toyota's plan, they want to make these cities a model for other countries. In this way, not only private transportation will become clean, but also the backbone of urban mobility.